The third test. All right, guys. You're good. Just like the next graded thing. So, the question that I was asked, it was number 2? No, number 1, right? 2 from the quiz?
Yeah.
Or from the
Sorry.
from the practice test? Okay. There it is. Oh yeah. Okay, this is perfect because that goes right along. Okay. All right, so guys, all right. There's a shortcut method for a lot of different things in mathematics. I really dislike teachers who only teach the shortcut methods because they are setting students up for failure. Because if you don't know why something works, you don't have any foundation to build off of. So there is a shortcut for if I have it prime factor. It's a beautiful shortcut. It goes right along with the idea. What does GCF mean? Greatest common factor. Can somebody say that in a more conversational way? Yeah, say I find this greatest common factor. No. What is the greatest common factor? What is that?
The biggest number that they have in common.
The biggest number they have in common when you factor them, right? Okay. So the biggest number that goes into both. You good? So obviously, real quick, guys, look. Obviously, does 5 to the 6th power go into the first dude? 5 to the 6th power. Would it go into the first dude evenly? Would it divide into him evenly? Can you guys see how to tell? Can I divide this first number by 6 5s evenly? Can you see why? I definitely cannot, yes? Okay, real quick. Why can I divide every even number by 2? Because it has a... Why can I divide every even number by 2? Why can I divide 21 by 7? Because 7 goes into 21. 21's got a factor 7 in it, yes? So why can I divide every even number by 2? Because every even number has 2 as a factor, yes? Are you guys with me? So obviously, I can't divide a number by some other number unless that number is in it. Can't divide it evenly, yes? So 14 divided by 7 is 2. Great. 15 divided by 7 sucks. Oh well. Because 15 doesn't have a 7 in it. How many 5s does the first number have in it? 5. Can I divide the first number evenly by 5 to the 6th power? Would 5 to the 6th power go into it evenly? Hell no, right? You guys see that? No? Why can't I divide 14 by 4 evenly? It only has a 2. It doesn't have 2 2s. It doesn't have a 4, yes? So why can't I divide 14 by 2 squared? Because 14 only has 1 2. Does that make sense by itself? Now just extend that idea. That idea is not only contained in small numbers. How many 5s can I divide this guy by evenly? How many 5s would go into this evenly? 5. Okay, so can I divide that first guy by 6 5s, by 5 to the 6th, evenly? What's the most number of 5s that I could divide this by evenly? 5. So can I divide that one by 5 to the 6th evenly? No, hell no. Same reason I can't divide 14 by 2 squared evenly, because 14 only has 1 2 in it, yes? Why can I divide 28 by 2 squared? Because 28 has 2 2s in it, yes? Yes. Alright. So the GCF is the biggest number that is a part of each of those numbers. Is 5 to the 6th a part of this number? No. Is it a part of that number? Good for him. But it does nothing for the first two. So what's the biggest amount of 5s that they both have in them? 5. The other dude's got 6. Good for him. Screw him. Back. They both have 5 5s. You guys, how many 3s do they both have? 2. So isn't that the biggest number of 3s that go into both of them? Isn't 5 the biggest number of 5s that go into both of them? Yes. All right, how many 11s do they share? 2. How many 17s do they share? None. All right, so what's the GCF? I could put this together if I had a pen. If I had a pen. There. And if I had my glasses. Oh, there. So we got GCF would be the smallest power I see, 3 squared times 5 to the 5th times 11 squared and no 17s because they don't share any 17s. That is the GCF. I don't really care if you multiply it out because it's going to be this big ass number. It's not going to really show me anything. Right? But that is, whatever that number is, it's the biggest number that goes into both. You guys with me? Does that make sense? This is the reasoning. So it's so freaking kick-ass. GCF, smallest power on everything. LCM, biggest. So real quick. Who's got more 3s? Which of those two numbers? How many does he need to have the same amount as him? 2. And then they would both have, and that would be part of the LCM. That would be part of the smallest number they both multiply up to be. Let this make sense. That second dude is missing a couple 3s. Yes? So if I gave him a couple 3s, they would both have 3 to the 4th. So the smallest number they can multiply up to be will include 4 3s. Because they could both multiply up to have 4 3s. Do you guys see that? Do you see that? LCM is the smallest number that both of the numbers can multiply up to be. Yes? One of them has 4 3s. The other one's only got 2, so I could multiply the other one by 2 more 3s. They would both have 4 3s. Now, if I just keep going through all my factors, I just keep doing the same thing. So to get the LCM, I take the highest power I see, because that would be what they could all multiply up to be. So what's the highest power on the 3? Yeah, 3 to the 4th. What's the highest power on the 5? 6. What's the highest power on the 11? And what's the highest power on the 17? That would be the LCM. That is the smallest number they can multiply up to be. Another way to look at the LCM is the smallest number that you can find both numbers in it. Can you find 2 3s in there? Can you find 6 5s? Can you find 5 11s? And can you find a 17? Can you find 4 3s? Can you find 5 5s? Okay. So there are 2 kind of ways to look at it because both ways have the same idea. It is the smallest number that you could find both numbers in. That's another way to think about it. Or it's the smallest number both can multiply up to be. Does that make more sense? Okay. So of course, the problem on the quiz, you had to first give yourself the list of factors to look at, and then you could do that.
He's the smallest number control at that point?
Yeah, the least common multiple. What is a multiple of a number? Like, give me a multiple of 6. 3 is a factor of 6. What is a multiple of 6? 36 is the multiple of 6. 12 is the multiple of 6, yes? You guys with me? So that's why LCM is the smallest number they can multiply it to be, because the least common multiple. The smallest number both multiply to be. LMC. Smallest, least, multiple, M, thing they both multiply to be common, least common multiple. Is that cool?
Yeah.
And that idea leads to this method. So for yourself, you wanna, the more you understand the idea behind a process, the easier time you're gonna have to apply the process. Because it's gonna be less like memorization and more just doing what's right. Okay, is that cool? Can you guys now, if you made a mistake on the quiz, do you feel confident to redo that? Some of you guys are like, especially because I have a calculator now. Come on. Real quick, Meg, I'm sorry. A lot of us had some trouble with 98. What number do you know definitely goes into 98? So 2, because it's even, right? So you could even do a little long division for 98. What's a better way to divide 98 by 2? Isn't 98 100 minus 2? What's 100 divided by 2? 50. What's 2 divided by 2? 1. 50 minus 1 is 49. Yeah. If 50 doubled is 100, 49 doubled is 2 less. 98. Do you guys understand what I just said? 50 tripled is what? What's 50 tripled? What's 3 times 50? 150. So what's 3 times 49? It's 3 less. I really want this is so cool. 3 times 50 is 150. 3 times 49, I have 49 threes instead of 50, so I just gotta subtract 3. If 3 times 50 is 150, 3 times 49 is 147. 1 less 3. Alright. Anything else about that idea? How to find GCF LCM with the prime factor? Because I know you guys know about the set intersection method. And some of you guys were doing it that way. Which is not what I asked for, right? Okay. Yes?
Can we go over, number 3 on the quiz?
Yeah. Oh, on the quiz. How do I check to see which fraction is bigger in general? What you got, Jeff? Yeah, sure. What's kind of the shortcut to see which fraction is bigger? They don't have the same bottom, so that sucks. You can't really compare them directly. You could potentially reason your way, you could write a little paragraph, but why do all that shit? What's the shortcut? What's the quick way to do this? Yeah, cross multiply. So if you do 19 times 3 and 17 times 4, let's see if you can apply the idea I just used. What's 3 times 20? 60. So 19 times 3 is 1 less 3, 57. This one, 10 times 40 is 10 times 4 is 40, 7 times 4 is 28, so 68. So which way should the sign go? What should I put here?
4/19
Huh?
4/19 is big.
Oh, so 3/17 is less than, okay, yeah. And just in case, I don't think I've said this, but just in case you have trouble with the sign, because you don't really work with inequalities like a ton, the less than looks like an L that fell over, yes? You guys see that? The less than looks like an L that fell over. Fell over. Yes? I think it's better than the alligator, but you know, whatever. Okay. Yes?
So for that one, I multiplied, so like with this problem, I was multiplying 19 with just 17 and 17 to 19.
Sure, you made LCD, which is basically what this is a shortcut of.
Oh, gotcha.
I know that if I multiply by each one,
Yeah.
I'm gonna get the same bottom, so then this just focuses on the top, because that's all that really matters. And that's why this is a little bit of a shortcut.
Yeah, yeah.
But if you did build them up, I'm not gonna count that wrong,
Okay.
that's correct. It's just you wrote a little more than you had to.
Yeah.
real quick, what was it, 412, 927, right? Okay. So if these were equal, that would mean 412 over 927 has to reduce to be 4 nines. Right, which means, you guys gonna, so when I first look at this problem, I don't know if it's equal. But at least one person kind of circled the 4 and the 9 here, and we're like, and I'm like, well, it's not good enough. Does 4 go into 412? Yes, how many times? 4 goes into 4, 1. 4 goes into 12, 03. 103. Does 9 go into 927? 103. Yes? So the 103s would cancel, you'd be left with 4 over 9, so that one's equal. So we can use, we have these. I know 4 goes into this because the last 2 digits are divisible by 4. I know 9 goes into this because when you add them, you get a multiple of 9. Yes? Okay. Maybe. Okay. Anything else specific before we do this stuff with this business? Because I did tell you I'm going to have at least one problem where you have to do, probably 2. 2 little problems you have to do with me, like we've done in the past. Yay, Jeff, I love it. It's not anxiety-inducing at all. So I kind of want to go over these manipulatives again because it's been a little while since we used them. So anything else specific for the moment?
Could you go over 1 on the practice test?
Anyone I want to? I'm joking. Okay. In general, real quick. If I factored something like this, do you guys remember how to tell how many total factors it has if I made a full list of all the factors? Do you guys remember how to tell how many factors it's got? We started saying something. Or my head's kicking, I'm hearing voices. Anybody? How do you tell how many? We had a little thing we could do.
Multiply the x.
Not the exponents directly.
So you multiply the 7 by 1, 3, 7, like 2, 3?
No. Alright, so listen. Real quick. Do y'all agree? I really want this to make sense. Don't even multiply that number out. But can somebody tell me if 21 is a factor of it? Is 21 a factor of whatever that number is? Come on, you can do it. Come on. Does 3 go into that number? Does 7 go into that number? Does 21 go into that number? Of course it does, because there's a 3 and a 7, yes? Does 7 go into that number? Yes. Does 3 go into that number? Yes. Does 1 go into that number? Cool. Gotcha. Yes? So, does 1 have a 3 in it? No. Good, Jeff, right? It's a weird ass question. Oh well. So, if I'm going to put together all the numbers that go into 3 squared times 7, I could use no 3s. I could use 1 3 like we did for 21. Or I could use 2 3s. And so 9 would go into this number, correct? So how many options are there for how many 3s I could use? 3. What about 7? I could use no 7s, like I did to say 3 goes in, or I could use 1 7. Yes? How many options are there for how many 7s I can use? 2. 1 more than each power. Yes? So then how many total things could I do? It would be 2 plus 1 times 1 plus 1. 3 times 2 is 6. What number is that? 3 squared times 7. 63, I like it. To do 9 times a single digit, 9 times 5, 1 digit less than 5 is 4, and then put the number next to it that adds to 9, 45. 9 times 3, what's 1 digit less than 3? 2. 2 plus what is 9? 2 plus what is 9? 2 plus what is 9? 7, so 27. 9 times 3 is 27. Alright. So that is how I can find out real quick. Is 3 a prime number? Yes. Is 7 a prime number? Yes. So what is wrong if I had this instead of this? If I had 4 squared times 5, and I do all the same stuff, 2 plus 1 times 1 plus 1, because that's 5 to the first, yes? I get 3 times 2 is 6. I did a mistake. I made a mistake. I did something wrong. What did I do wrong? I didn't break the 4 down, right? 4 would be 2 squared, and I have 2 of them, so it would be 2 to the 4th, which would change that word, yes? You guys see that? 4 squared is 4 times 4, which is 2 times 2 times 2 times 2, yes? So this is actually 2 to the 4th times 5 to the, so what should be here? 4 plus 1, which makes this completely different. Okay. So doesn't it make some kind of sense? I can't just stop wherever I want to, because then the answer is all different. So to be able to apply this little trick, I have to take everything down to prime factors, correct? So now look at the problem. You don't know what the hell P is, and you don't know what the hell Q is, but I told you they're prime. What are the powers on each? Yeah, when it doesn't say, it's the first power, right? So then how many factors will this have? What's the process? Are these prime factors? Yes, so it's not this problem, is it? It's already a prime factor. So how do I get the total number of factors? Do the same thing always. Same thing we did here. Same thing we do every night, Pinky. What do I do? I do the same thing. So what do I do? I do the same thing. So what do I do? 1 plus 1 times 1 plus 1, 2 times 2, 4. So I don't even know what P and Q are, but it's going to have 4 factors. Let's test this. How would I test this? Well, just give me 2 prime numbers. Can somebody give me 2 prime numbers? Do it again, sorry. Do it, what? 7? 5. Okay, what's 7 times 5? What are the factors? We already know there should be 4 factors. Yes, that's what we just proved. 1, what else? Goes into 35. 5, 7, 35. There's 4, yes, okay. So any 2 primes you give me, they're going to be to the first power, so they're going to have 4 factors. So that was just saying, it doesn't even matter what P and Q are. If there's just 1 P and 1 Q, it's going to have 4 factors. Not something you have to memorize. All it is an application of the idea. Okay. So what if I had like P squared times Q? And I said, how many factors? P and Q are prime, P squared times Q. How many factors will this have? No. 2 plus 1 is 3. 1 plus 1 is 3 times 2 is 6. So you increase each exponent by 1, and then you multiply them together. Why do I do that? Because how many P's could I have in my answer? None, 1, or 2. It's always 1 more than the number I see. Because the number I see does not include the option that I can just not take it at all. Just that's the first option. Just don't even take it. Here, let me show you something tangentially related. Can you guys help me out? 48. Give me a way to factor 48. Huh? 2 and 24. Okay, cool. Keep going. 24 is 12 times 2. Keep going. 3 and 4. Keep going. 2 and 2. I like it. So this is 2. Let's see. 1, 2, 3, 4. And then 3, yes? So right there, what's 2 to the 4th? 16 times 3? 48. Okay, so if I want to create a number that goes into 48, I could take either none or 1 3, or none or 1 or 2 or 3 or 4 2s. So for example, what is 2 cubed times 3? I can take, what's 2 cubed? If I take 3 2s and 1 3, what's 8 times 3? 24. Is 24 a factor of 48? I can build factors of 48 by taking up to 4 2s and up to 1 3. So what if I take 2 2s? That's 4. Does 4 go into 48? Does 4 go into 48? Yes. So I can build factors if I just get the DNA of it. If I just get it all the way broken down, I can take up to 4 2s and up to 1 3. And any combination makes another factor of 48. That is the basic idea that leads to this add 1 to the power, because it has to do with how many choices I can make. Okay, maybe? Screw you, math board. Does your God make sense now? Okay. So looking back at this, do you all agree that's going to be a big number? I can build a number that goes into this number. For example, this number goes into that number. Yes? This number divides evenly into this number. Is that the only number that divides evenly? Did I have to pick 2 3s? How many 3s could I have picked? 0. Real quick, I'm sorry. You're about to tell me. I just asked you a question. You're like, I'm answering, Joe. Sorry, just one thing. Does everybody see how I built 3 squared times 5 times 11? Right? I took 2 3s, 1 5, because it's got 4 3s, 5 5s, and 2 11s. Yes. So I just take and put together. I can just put together all these different factors. So I'm sorry. Go ahead.
So I was gonna say, you could use anywhere from 0 to 4.
Good. So how many options is that? 0,
5.
1, 2, 3, 4. That's 5 options. Yes. That is why I add 1 to the power. So if number 2's question was, how many factors does this number have? It would be 5 times 6 times 3. That's how many factors it would have, because of how I can put factors together. Okay, maybe. Okay. I know on one level this is remarkably boring, but I'm hoping somebody out there sees how neat this is. This is what I meant by that's the DNA of the number. So if I just take a little bit of the DNA, I could make this little creature that's related to that. So there's a whole biology of this that I could kind of go, no. All right, push button. Okay. What about number 3? I love number 3. You would, you weird guy. Can somebody tell me what's true about any positive number? What's a mathematical statement you could make for any positive number? That's a weird question, but I just want to see. Tell me anything you know about a positive number. What must be true? If it's a positive number, what must be true about it?
It's greater than 0.
A thing. It's greater than 0. Yes? So when I say, is that a positive number, I'm saying, is that greater than 0? So you're translating my English into more mathish. Yes? And then you guys are sitting there right now going, that does not help me, Jeff. You have not helped me. I think that's your job. I'm sorry, but what is that? Is everybody with me on that? Positive numbers are greater than 0. You're like, yeah, I know that shit. I didn't know it would help here. I know this is less than, therefore, what if that wasn't there? How would I start to tell what the relationship is. We just did one like that a second ago. Cross multiply, yes? Alright, go ahead, cross multiply. Is that cool? But they already told me, thank God they told me, because I don't know what the shit X is, and I don't know what the shit Y is, but they already told me it goes this way, yes? They already told me that, yes? So normally I would have the numbers, I wouldn't know what the inequality symbol was, and then I just look, which number's bigger. This one they already told me, because there's unknowns over it. Dear God, tell me something. Can you guys get 9x minus 5y from that somehow? Because that's what I'm asking about, right? You guys see 5y and 9x? If you do this, you should go, oh my God, I've got shit from what he's asking me about. How do I get those together? Mathematically, what do I do to get 9x minus 5y to show up? How many sides do I have in my problem? How many is 2? So how do I get 9y minus 5x? Subtract 5y, yeah. So then 5y minus 5y is 0. And then 9x minus 5y is 9x minus 5y. Somebody read this for me. What's it say? 0 is less than that. So what's, if I turn around, if 0 is less than this, this is greater than 0. Which means that is what kind of number? Done. Done. Yes? Okay. Is that an easy problem? No. But I'm hoping when if I put it like that, you realize, oh, cross multiply gives me the things that are part of the question. I get 9x, I get 5y, then maybe you see the next step. Positive means greater than 0. This is an inequality. It's already kind of like baked in. Maybe I can get there. Okay. All right. I'm sorry. I took over for a minute. Any other specific questions before we try this stuff out? Okay. So let's do this. This might be a good place to do this. A little breather in the middle. I didn't really put like little pictures to break you guys up. I'm gonna let you guys kind of get together. We'll see if that works that way. All right, let's see. 2, 4, 6, 8, 10, 12, 14, 16, 17. Okay. You get into groups of, the rest of you get into groups of 3 or 4. Can you guys do that? I can help if I need to. You can do it. You can do this. You guys are so excited. Are you guys are?
Yeah.
Yeah. I'm assuming. I'm sorry. It's too much. All right, guys. So maybe Enoch, you want to work with those guys back there? Yes. All right. So notice on the handout, I've got the manipulative problems on the very first part, yes. And then I got two explain this to a student problem. I thought it might be good for you to discuss with each other when you hit those problems. Different ideas you have as to how to address the student. Because some of you guys really get that problem, you have to talk to the student. Some of you guys don't quite get that. So whenever you ask that kind of question, pretend like you are talking to the student and write down what you would say. All right, go for it.
Okay, but I have to explain it. Is it recording?
Yes.
Okay, what's up, vlog? Welcome back to Math 125. Let me give you guys a quick tour. So first we have my Christmas tree with the best. You zoom in on that. That's beautiful.
Where are we at? Oh, here.
The star. Okay. Then we have. Wait,
I'm gonna get
these?
fired.
These are like rockets. I don't know, rockets or lava lamps. Then we got red Christmas trees because we don't discriminate on colors. This is an orange. That's a lemon. These little ones are pumpkins, and then that's a carrot.
Oh,
And then this is my giant tomatoes. Now wait, this is my my son. Okay.
Okay.
These are my blueberries.
Well, they gotta grow it somehow, right?
People all over the world come for these giant blueberries.
Damn straight.
Yep.
All right.
Okay.
Thank you.
This is the outro for the video.
You did better than David because he.
I'm gonna rub that in his face.
Damien asked me if you could do an outro.
I'm gonna rub it in his face.
Oh, thank you. All right, guys. Anything that you want to focus on now from the practice test? Any other? Yes. 4. Oh yeah. Okay. Perfect. Does anyone? Did anyone look at 4? Did anyone do number 4? Do you have an idea? What'd you do?
I just did it as whole numbers, so I did 182 divided by 6, and it was 30.
Wait. Number 4?
Oh. Oh my god, I'm sorry.
You're good.
Wrong side. So I put parentheses around 9 over 13 times 5 over 8, and then I put parentheses around 3 over 8 times 9 over 13.
Okay, sure. That doesn't really change anything, but yeah.
Yeah. And then I did the parentheses first. So the first one is 45.
Oh no. Okay, no.
No.
I'm sorry. What? I'm sorry, Sean. You're fine. What I really want to have happen here is I want you to be able to do this in your head. Use the strategy.
You can combine 5, 8, and 3.
You cannot because that would not be following order operations. So I can't right now do 5/8 plus 3/8 is 8/8. Because nowhere in there does it say 5/8 plus 3/8. It says 9/13 times 5/8 plus 3/8 times 9/13. I don't see 5/8 plus 3/8 in there anywhere. Now, I do like you put parentheses. It didn't really change anything because it was going to multiply first anyway for PennDOT.
Yeah.
But what does each piece have in common? So can't you undistribute it? And then you do uncover what? If I take a 9/13 out, what am I left with here?
5
Plus 3/8. What's 5/8 plus 3/8? Right? And that's like a little tiny head 9 there. Okay, there it is. 409. What's that? Is that okay?
So I just did like more than I should have, because I just multiplied 13 by 8.
Yeah, too much. I mean, they would end up with like denominator, but then
Yeah.
it's a lot of work. This is so quick,
Okay.
right? That's what I mean by strategy. Strategy is distributed property, compensation, all that kind of stuff, yeah? Anything else? I can give you, let me go ahead and give you the answer key. So I'm not up here redoing everything I've done already. 19? Okay.
Oh, there was a mistake right there. I need you, what? It should have been, oh yeah, 3. Oh, they said summer, I'm not here. When did you have that line different too?
So somebody had a question about 19.
Oh, that's right, I didn't know, I didn't say that.
Oh yeah, okay, let me say this. 19B was a lot more involved than I meant it to be. So you'll see on the key that I just sort of stop at one point. It's a little more than I meant it to be, but it's okay. At the very least, I wanted these represented as fractions. You multiply by the reciprocal, you cancel out something, and you can stop. 19A, just how do you write those as fractions? Don't look at the key. How do you write those as fractions? What place is this in? Thousands. So I can do this. I can literally 13,467 thousandths. This would be what? By the way, real quick, 1 in 13 hundredths, isn't that 100 plus 13, isn't that 113 hundredths?
What? Crazy.
I know. That's crazy. And then, how do I combine these? What do I need to do?
Can you times 1,300 by 10?
And then I got like the denominators. And then you just add the tops. And then it's just whole number addition, yes? Okay. And then the last thing you do, since I started with decimals, you're going to end with decimals at the end. Now, of course, this is a step in the direction of lining the decimals up and doing it that way. And this, of course, is where some of the parents are going to have an issue with you. Because they're going to say, why are you show my student how to do it? What are you doing? And they're not all good. I'm sorry. That's not every parent. Some parents are going to be exactly like that. Some parents are going to be worse. Most parents are going to be better. All right. In 19b, you write them as fractions. You multiply their circles. Some of the tens cancel. Yeah. Okay. Basically, that's what that is. Just write as fractions and do as much as you can. What about? I'm really curious about 20b. If you guys try 20b, what'd you do? Can't do that.
Do you put a decimal in zeros and all the other places?
Yeah. You guys remember how to do this? Sorry. If I want to do this, I can make this go down by 1, I can make this go down by 1, and then it's a lot easier to do, yes? Equal additions? Equal additions? If I make that go down by 1 and I make that go down by 1, the difference is the same. So watch this is so cool. So a little bit of what Carlton said, if I give it all these zeros, but do you see how that's going to desperately suck? Because borrowing is not difficult, but it is a place that gets kind of messy, it's easy to make a mistake. So what I'm going to do is I'm going to take this down by effectively 1. Do you see that? And then what do I take this down to? Got to go the same direction so I keep the distance the same, yes? The whole idea is subtraction tells you the distance between, and if I move them in the same direction, the distance is the same. And then that's easy as shit. There's no borrowing then, yes? Yes. Is that okay? No? I mean, I say simplify directly, but I'm not going to borrow. That's going to drive me insane. So I'm not going to do it. What's really funny is when you borrow, aren't you going to get a bunch of 9s? So this one just sort of gets to the point. The other two you just have to set up and do. Right? So I'm just checking to make sure you remember how to move the decimal over when you divide. And I'm just checking to make sure you know how to multiply and then move the decimal over enough for part C. Yes, is that okay?
Yes.
How many times will you move the decimal over on your answer for part C? 5 times. 3 up there, 2 down there, so 5 total. Yeah. Anything else you wanna look at? Would love to look at the sun. Don't look at the sun. Yes. 12? Oh yeah. So real quick, what's the reciprocal of 1/10? And I know it's not the question. What's the reciprocal of 1/10? 10, yes. What's the reciprocal of 7/4? So what is the one thing that's different about that question, number 12? Yeah, it's a mixed number.
So why don't you just like bracket? Do you do 8 times 10 is 1?
Yeah.
Or 10?
Make it an improper fraction, and then you flip it. Yeah.
Okay.
So if it was one fraction, I could flip it easy. It's like a break almost. Okay, sorry.
There was someone who was spiky mohawk earlier.
What's that?
There was someone who was spiky mohawk.
Me? Big ass. This is Spiky Mohawk delegation. I didn't know there was visiting today. Alright guys, I'm sorry. When you become a teacher, it might be better to not be the source of distractions yourself. Everybody look over there! Anything else you wanna? There he is! Everybody look. It's kinda like Statue of Liberty's cousin.
That's crazy.
Man, that takes me back to the 80s.
Like I have to try, like.
Everything goes back. Alright guys, anything else? If you're looking over the answer key, do you see any thing that doesn't really jive with what you got? I'm averaging about a 97 on my answer keys.
So with 7, instead of x equals 10 and 11, if we wrote just one of the two, would we get docked points?
Oh, I see. It's kind of like the idea I said Homer values. Yeah. And if there were 7 answers and I said this and you only gave me 2 of them, I can't take points off. But if I said find all Homer values, but on this one there's only 2, so you have to give both of them to answer the plural. But you're right, I'd have to be more specific if there were more options. Maybe.
What did the guy, I mean, I can see that he clearly did something wrong, but what did the guy do in number 9 that was wrong? Like, exactly.
Yeah, this is neat. This is an example. So, I don't know if you guys really believe me when I say this kind of thing, but to be a really good teacher, and I don't know if I always do this, I'm not trying to say, oh, look at me, I'm amazing, but to be a really good teacher, I strive to see where the logic makes sense from the student's perspective. Because if they at least applied something correctly, but they did it in the wrong place, that is a thing to tell them. Oh yeah, if it was this, then you did it perfectly. And unfortunately here it's this, so we have to do it differently. Everybody write this down somewhere. Write 3 times 20 over 21. Yeah. Now put 3 over 1, just to make it easier to look at. Yes, that's what we normally do with full questions. Okay. So 3 over 1 times 20 over 21, is that cool? What did the 3 and the 21 do in that case? They reduce, yes? So let me write down. So this totally unrelated problem I'm making you do. What was it? 21st. This would reduce, yes? And you would get 20 over 7, yes? Isn't that what they got? Isn't that what they got? Isn't that what they got? So this is a very common mistake on this. Because we tell them it's multiplication if it's sitting next to it. So they're like, all right, I gotcha, I hear you. It's multiplication, so I'm going to divide because that's what I... No, but what is it? What is the operation there? Addition. So you have to remind them, oh, I didn't give this person a name. Oh, student. It's understandable, it's easy to forget there's a plus sign there. What did I say? What did past Jeff say? Oh, identify the mistake. They multiplied. How would you explain this to the student? Oh yeah, so one other way that came to me was 3 and 21st is obviously bigger than 3. And the student would agree. 20 divided by 7, 21 divided by 7 is 3, so 20 divided by 7 is less than 3. So how could something bigger than 3 equal something less than 3? So I kind of took a route of how can you check to see that you made a mistake? Which is a good route to take sometimes because that puts agency back in their hands. I can check myself, right? What else did I say? Oh yeah, and then of course you remind them that it's addition. So I was hoping at some point I did that. It's just an unfortunate choice we made in history to write it like that and mean addition. You guys what? I mean, there are choices made as to how math is going to work. And unfortunately, they were sometimes on various substances, is what I'm going to assume, because they made some dumbass choices in some situations. And now we're just kind of stuck with it. So, that's what it sounds like you do. Anything else, guys? What about number 8? What do they do? Yes. How would you, if you haven't looked at my answer yet, how would you show them that it's wrong? How would you explain it to them? You could try to use manipulatives. There are manipulatives that break things down into 7s, believe it or not, but they're in the more expensive set. So like we've got the 8-pack of Crayola crayons. We don't have the 64-pack of Crayola. Yeah. So if you go to like a school that's got, really good property tax, big houses around it, you might have enough money to get enough resources to have more fractions represented. That's not where we are. You could use manipulatives, but let's say you don't have access to that at the moment. What would you say to them? I mean, what did they do wrong? They added a cross. All right, why is that wrong? They're not like terms. You remind them. You can do the whole thing, 3 chairs and 2 chairs is 5 chairs, but 3 chairs and 2 sofas is not 5 chair sofas. They have to be like terms to add them. And then you can go 4/5 plus 1/5 is 5/5. 4 things plus 1 thing is 5 things, yes? I've got 3 things and 6 other things. I don't have 9 anythings. Because, that's the first step to explain why that's not good. Maybe? To me, that's what's missing from explanation about fractions, is that we need like terms. And you can explain that before they do algebra. And then when they did algebra, like terms, they've already talked about it. Like terms literally means 3 chairs plus 2 chairs is 5 chairs. 3 chairs plus 2 dogs is not 5 chair dogs. Right? Go sit down, barks at you. Your chair's got a tail, this shit's going on. No. It's alright. Now the unfortunate thing, just to remind you guys, we have Tuesday off. Now, generally that's like a good thing to have a day off when you did it, but that means it's a week between now and when we take the test. So I would highly recommend, if you need to take advantage of the office hours, take advantage of the Math Science Center, all that kind of stuff, yes. And if you really need help and you can't make it to campus at any good time, then I can set up a Zoom or something. I think I told you guys that. Yes. Help. Yeah, everything's shut down. The whole school shut down. Yeah. Oh, that would suck. Students like, we have day off. No, you don't. Stressing here. No, everything's shut down. They might even close the gate at the front. I don't know. They don't really close that too often, but yeah. When you drive in, you'll see it. It's like swung open. You'll see a thing that's down on the side of the road. They swing it closed. Huh?
Like at the
On the three entrances, yeah,
Oh,
there's gates, they can swing closed. And they'll stop everybody. I'm gonna steal everything, damn it, the gate's down. It's like the monster coming to your house when you're little, they eat you and they're like, oh, it's lights on. Anything else? Okay, that's it. So I will see you next week. Have a good Tuesday off. If you or somebody you know is a veteran, I want to say thank you to them for your service, or thank you for their service or something like that.